force of gravity acts on the smaller object, down. The reason why they fall at the same rate is they have the exact same acceleration and the exact same initial vertical velocity.
Does that say 0 meters per second squared?
Yeah. So their accelerations are identical. The only thing that is going to change is the vertical, the j hat velocity, because horizontally there is no change. And so they will fall at the exact same rate.
Which means that they'll hit the ground at the exact same rate.
Yes. Which means that we could actually solve for v here. Assuming our numbers are accurate, let's just pretend that they are. Because if they hit the ground at the same time, if I need to figure out how much time was that one in the air, all I have to do is solve this problem, because the times are the same. So let's do it. We're going to use that equation again. Let's clean this up. Delta x equals VIT plus 1/2 AT squared. We're trying to figure out how much time does it take for that ball to fall 1.35 meters. Initial velocity, 0, times time, plus 1/2, 9.8 t squared, because we're making down positive. So I got 1.35 is equal to 4.9 t squared. Technically, there are two answers, two mathematical answers, but only one makes any physical sense. And we end up with .53 seconds. The answer is
well, I did the 1.35 divided by 4.9, which is 0.27, a bunch of others afterwards, and then the square root of that is 0.524.
all right. Seconds. All right, so we know how long it is in the air, so now let's figure out how fast that other one had to have been going. Because the velocity horizontally is changing, it's not changing, only the vertical is. All I have to do is just look at the horizontal part. I can use the exact same equation.
Wait, when we write in the time here is 0.524.
Yeah, I was just gonna jump straight
Okay.
to it. So I said 2 meters, the number I made up, is equal to VI times 0.524 plus 1/2 times 0 times 0.524 squared. That whole term drops out conveniently. And so my initial velocity would be 2 divided by 0.524. 3.9. It's always going to tell me the real answer.
Uh, 3.81.
81. Units?
Meters per second.
And technically, I had. So the fact that these two, that the vertical and horizontal can be separated becomes very powerful, and we can now solve problems, and we won't do this today, I'm just gonna set it up.
So then we change so the equation for initial velocity now becomes 3.81 meters per second plus 0 meter, or 3.81 meters per second I hat plus 0 meters per second J hat.
Yes.
Right.
You don't have to write the plus 0 meters per second J hat, but nothing wrong with it.
Got it.
All right, so now we can start dealing with problems of, I have a ball that is launched at an angle of, say, 37 degrees going 50 meters per second from the top of a cliff that is 40 meters tall. The ball is gonna go. Actually, one way it launched right there from the edge. How did I manage to? How far from the bottom of the cliff will it go? And so I've given height, initial velocity, there's magnitude and direction. First thing we're gonna do is we're gonna solve the problem of, we have an object being thrown up and down, how long is it in the air? And then once we know how long it's in the air, we can figure out how far it went horizontally. Yes, Ibrahim?
So will we be solving for like, or accounting for the rolling?
No.
No.
Because these formulas that we're using assume constant acceleration. As soon as it touches the ground, the acceleration is no longer constant. So that becomes a much more difficult problem.
Will we do that next semester?
No.
Not even in 152?
We'll deal with rolling at some point, but ish. But yeah, having an object hit the ground, it becomes more and more complicated the more reality you want to bring into it. And this is a first semester course. That's also an engineering thing,
Really?
not a physics thing.
But physics is engineering.
It requires the use of physics, but it gets to a certain point where it gets way too complex to solve mathematically, to come out with an equation for the math. And so it probably will come down to a lot of experimental stuff. They'll come up with equations based upon experimental, based upon trends in experimentation.
So let's start throwing stuff.
Well, that's how it begins. And then you get to engineering.
What does it say? Is it 50 minus, what is,
This,
yeah,
50 meters per second.
oh, 50 meters per second, okay.
I was not lying when I said my handwriting is getting worse and worse.
Sure you don't have doctors?
When I was teaching elementary school, I made sure I wrote very neatly.
Really?
Once I stopped teaching elementary school, I thought, oh, okay, I don't have to write that neatly anymore. And then I started getting a bunch of questions of, what does that say? Anyway. See you tomorrow. We got lab, it's already posted. Please print out a copy before you come in. And if you can't print out a copy because of technical issues, let me know. Have a wonderful day. And then, sort of the teaser, Thursday, this is the cliffhanger, what the answer is.
Oh, what was that one thing? So like you said, I had a quiz, the master set, what's the last one?
The line integral.
Yeah, line
Integral.
I just remember the word integral.
Line integral for what again?
For a parabolic flight.
Parabolic flight.
It's a Calc 2 problem.
All right,
Or Calc 3. I think it's Calc 3.
I'll get back to you.
All right. I'm looking forward to tears of joy streaming down my face when I read your work tomorrow.
Can I ask you a question? Okay.
What was that? When you told us that we got like an